Contents. 1. Representation Learning and NLP. 1.1. Motivation. 1.2. Why representation learning is important for NLP. 1.3. Basic ideas of representation learning. 1.4. Development of representation learning for NLP. 1.5. Learning approaches to representation learning for NLP. 1.6. Applications of representation learning for NLP. 1.7. The organization of this book. References. 2. Word representation. 2.1. Introduction. 2.2. One hot word representation. 2.3. Distributed word representation. 2, 3, 1. Brown cluster. 2, 3, 2. Latent semantic analysis. 2, 3, 3. Word 2 vec. 2, 3, 4. Glove. 2.4. Contextualized word representation. 2.5. Extensions. 2, 5, 1. Word representation theories. 2, 5, 2. Multi-prototype word representation. 2, 5, 3. Multi-source word representation. 2, 5, 4. Multilingual word representation. 2, 5, 5. Task-specific word representation. 2, 5, 6. Time-specific word representation. 2.6. Evaluation. 2, 6, 1. Word similarity, relatedness. 2, 6, 2. Word analogy. 2.7. Summary, references. 3. Compositional semantics. 3.1. Introduction. 3.2. Semantic space. 3, 2, 1. Vector space. 3, 2, 2. Matrix vector space. 3.3. Binary composition. 3, 3, 1. Additive model. 3, 3, 2. Multiplicative model. 3.4. N-ary composition. 3, 4, 1. Recurrent neural network. 3, 4, 2. Recursive neural network. 3, 4, 3. Convolutional neural network. 3.5. Summary, references. 4. Sentence representation. 4.1. Introduction. 4.2. One hot sentence representation. 4.3. Probabilistic language model. 4.4. Neural language model. 4, 4, 1. Feedforward neural network language model. 4, 4, 2. Convolutional neural network language model. 4, 4, 3. Recurrent neural network language model. 4, 4, 4. Transformer language model. 4, 4, 5. Extensions. 4.5. Applications. 4, 5, 1. Text classification. 4, 5, 2. Relation extraction. 4.6. Summary, references. 5. Retracted chapter. Document representation. 5.1. Introduction. 5.2. One hot document representation. 5.3. Topic model. 5.3.1. Latent Dirichlet allocation. 5.3.2. Extensions. 5.4. Distributed document representation. 5, 4, 1. Paragraph vector. 5, 4, 2. Neural document representation. 5.5. Applications. 5, 5, 1. Neural information retrieval. 5, 5, 2. Question answering. 5.6. Summary, references. 6. SEMEME knowledge representation. 6.1. Introduction. 6, 1, 1. Linguistic knowledge graphs. 6.2. SEMEME knowledge representation. 6, 2, 1. Simple SEMEME aggregation model. 6, 2, 2. SEMEME attention over context model. 6, 2, 3. SEMEME attention over target model. 6.3. Applications. 6, 3, 1. SEMEME guided word representation. 6, 3, 2. SEMEME guided semantic compositionality modeling. 6, 3, 3. SEMEME guided language modeling. 6, 3, 4. SEMEME prediction. 6, 3, 5. Other SEMEME guided applications. 6.4. Summary, references. 7. World knowledge representation. 7.1. Introduction. 7, 1, 1. World Knowledge Graphs. 7.2. Knowledge Graph Representation. 7, 2, 1. Notations. 7, 2, 2. Transay. 7, 2, 3. Extensions of Transay. 7, 2, 4. Other models. 7.3. Multi-source knowledge graph representation. 7, 3, 1. Knowledge graph representation with texts. 7, 3, 2. Knowledge graph representation with types. 7, 3, 3. Knowledge graph representation with images. 7, 3, 4. Knowledge graph representation with logic rules. 7.4. Applications. 7, 4, 1. Knowledge graph completion. 7, 4, 2. Knowledge guided entity typing. 7, 4, 3. Knowledge guided information retrieval. 7, 4, 4. Knowledge guided language models. 7, 4, 5. Other knowledge guided applications. 7.5. Summary. References. 8. Network representation. 8.1. Introduction. 8.2. Network representation. 8.2.1. Spectral clustering-based methods. 8.2.2. Deep walk. 8.2.3. Matrix factorization-based methods. 8.2.4. Structural deep network methods. 8.2.5. Extensions. 8.2.6. Applications. 8.3. Graph neural networks. 8.3.1. Motivations. 8.3.2. Graph convolutional networks. 8.3.3. Graph attention networks. 8.3.4. Graph recurrent networks. 8.3.5. Extensions. 8.3.6. Applications. 8.4. Summary. References. 9. Cross-modal representation. 9.1. Introduction. 9.2. Cross-modal representation. 9.2.1. Visual word 2 vec. 9.2.2. Cross-modal representation for zero-shot recognition. 9.2.3. Cross-modal representation for cross-media retrieval. 9.3. Image captioning. 9.3.1. Retrieval models for image captioning. 9.3.2. Generation models for image captioning. 9.3.3. Neural models for image captioning. 9.4. Visual relationship detection. 9.4.1. Visual relationship detection with language priors. 9.4.2. Visual translation embedding network. 9.4.3. Scene graph generation. 9.5. Visual question answering. 9.5.1. VQA and VQA datasets. 9.5.2. VQA models. 9.6. Summary. References. 10. Resources. 10.1. Open source frameworks for deep learning. 10.1.1. Caffe. 10.1.2. Theno. 10.1.3. TensorFlow. 10.1.4. Torch. 10.1.5. PyTorch. 10.1.6. Keras. 10.1.7. MXNet. 10.2. Open resources for word representation. 10.2.1. Word 2 vec. 10.2.2. Glove. 10.3. Open resources for knowledge graph representation. 10.3.1. OpenKE. 10.3.2. Scikit-Cache. 10.4. Open resources for network representation. 10.4.1. OpenNA. 10.4.2. Gem. 10.4.3. GraphViet. 10.4.4. CogDL. 10.5. Open resources for relation extraction. 10.5.1. OpenNRE. References. 11. Outlook. 11.1. Introduction. 11.2. Using more unsupervised data. 11.3. Utilizing fewer labeled data. 11.4. Employing deeper neural architectures. 11.5. Improving model interpretability. 11.6. Fusing the advances from other areas. References. Correction 2. Representation learning for natural language processing.